So I want to go over an article I just wrote recently, and we're going to just look at how to do the Laravel RAG system in 4 steps, though the 4th step is a bit long, could be 5 steps. All right, let's jump into this. And all the code is online, and you can go here and follow along. The branch is main, and then as I go I make new branches, so you could just see it as it goes, or go to the last branch and just have everything. Alright, so setting up the vector database is actually pretty easy using the Laravel vector library. So we're just going to do a composer install on this guy, and then we'll run the migrations and set to go. The migrations are pretty cool because it actually sets up the extension for you, which was really nice actually. And I'm just using Herd. You can use DB Engine, you can use Postgres app, and the Postgres app has the ability to run the vector extension. So if we were to look at that particular migration that library makes, we can see right here it just enables that extension, which you can't do in every version of Postgres. You got to make sure you have one that allows that, which I think they almost all now do. I just was having trouble before with the one that came with DB Engine. All right, so that's it. We have we have the vector set up, and there's little details in there when you go into the model, and you'll see it later on in the code, but when you go into the model, we'll reference it there and so forth. All right, so now let's go make that model. So that's the next step. We're gonna just make the chunk model, and I called it chunk. Basically, it's gonna be small parts of a document. So if you upload a text file that is large, or a PDF that is 100 pages, a chunk could be 5 chunks per page, just depending on how dense those pages are. And we're going to do a little bit of overlapping, and you'll see that in the code as well, and we're going to look at that shortly. So the model just represents that particular idea of a chunk of data. Typically I would have actually another model that's the parent that represents the full document, and it won't have all the document info, it just links to all the chunks. And so we'll just set up that model and get going there. So that is on a different branch. So let's go see what branch that is on. The model setup. So let me go check that out. I'm actually on the last branch. I'll just stay here for a moment because it doesn't really matter at this point. All right, so when I created that model, which is the only one we really care about this time, we now did a few things that are gonna just worth pointing out. So we're using the vector extension now in the vector library to make vector enabled columns, and I gave them these different names because, and I link it in the article, these embedding systems can have different sizes, and it was a way to get around not having the right size, and it works. You'll see some of the code, it's not that kludgy, and it's what I was told to do by the author of the library, so maybe there's a better way to do it. And as we use this, you'll start to see more of how these fields are being used as we dig in. It will make more sense. And then the model itself, it has neighbors, and that was key in the instructions, really simple, and then you just cast all the particular items. This metadata you can ignore for now. And of course there are tests, so as you work through this you can always look at the test to get a sense of how things work. So you can see it's just a factory test there, but later on we do some tests to prove it can chunk and store chunking and everything. Alright, let's see what is next. Okay, so we are going to dig into watching it work in a moment. But basically, we're going to now add the LLM driver. So I just grab a bunch of code at this point. You can look at the branch to see what gets pulled in. But basically, I dump a bunch of code in here, which could be a standalone library. I will get around to it one day. And in here, we just abstract out clients, because I don't want to just talk to one thing. I want to talk to anyone I want, depending on the task, depending on so many things. In our demo, we'll do a little bit of Claude, we'll do some of Olama, and I don't know if we did OpenAI in this one. And it's pretty easy to use, and you're going to see as we use it how it works. We're also going to install Spatty data. They all want the same structure, and they'll return the same structure, so we can just drop in any client we want. Alright, what are we going to do with this? Once we set it up per the instructions and once we load it, we're ready to go. So I'm going to use Tinkerwell here, and we see that I can use Tinkerwell to get all the files out of a folder and make embedded data. So what does that mean? Let's go look. Alright, so we switch over to Table Plus because I just enjoy using the interface more than other of the tools. And just so you don't get scared away, I wanted to show you this. You might see this big list of functions. Just ignore that. Postgres, once we install the vector extension, we'll just have a lot of that. But now we're going to look at our chunks table, and you'll see it's full of data, but we're going to get rid of that because I want to show how this whole thing works. So let's truncate that. Alright. We're going to run this script. It's taking all the files inside the fixture folder, which is a bunch of, not even that much, markdown files. And because we're building a RAG system, we have to feed it good data to then search. So in this case, it's just a few documents from Laravel's markdown docs for their website. And we're going to just load those files into the system by giving them chunk text. So we're handing it to that class. So if we just look at that class, you'll see here I do a lot of dynamic facades or real-time facades. So I just like them. So just keep that in mind. Alright, so all this guy does is take that large bit of text, or any size, and it makes that overlapping process happen, where it says how big is the text, how big do we want it, how much overlap, and it starts to break it up and returns an array. Then we iterate over that array and just turn it into a chunk. And we don't want to repeat ourselves, so I can do update or create. And then it will, and this is the key part, it will take that facade, so whether it's OpenAI or Llama is nice because you can run it locally and you're not paying for embeddings. OpenAI you have to pay. And in this case, we're going to take whatever driver I happen to be using. So the driver I'm using is not the mock one, it's whatever is being loaded in the .env. Now the mock one's nice because you can do some things and see things happen. Because we have Llama running locally, we can use that. Now the mock is nice because it's fast, and we don't need it for testing the PHP unit test level, but sometimes mock is nice when you're just doing some UI work and you want to see full cycles of requests happen. Alright, so we then come down here and we take that driver and we load it, and we get OpenAI or a Llama, and in this case we saw a Llama, and then we tell it to do the embedding. Let's go look at that. So the embedding driver, our function, if we look at the services, we are calling the facade, which is linked to the client, which just says, hey, what driver do you want? We want the Llama driver. And we go look at embed. It's crazy how easy this is. We just hand it the text. It just says I'm going to hit that embed path, a post request, HTTP, and it passes the model we want to use, which is inside of that file we were just looking at, and gives it the prompt, and that's it. It's going to return the embedded response, which we grab and add it to this DTO, which just returns it as a vector. Okay, so when we get that from the system, we can then save the results of that, and we put it here. Now again, this is a little abstract because we don't know what column to use, but we do because we know the driver we're using has a particular column attached to it. So if we look inside the drivers and we see that our driver is Llama, and then we see that our model for embedding is the MXBI model, then we're set to go. In the article, we'll talk about how to install that, really easy. But if you're using OpenAI, great. It just will say, okay, you're using OpenAI and the embedding model defaults to this guy. But you could change it quite easily. Alright, so now we add that back to the right column, and we're set to go there. Let's prove it. So we're going to run. We have nothing in the database for chunks. We're going to run this guy here, and it's going to hit Llama like crazy. So now we are really depending on actually nothing here. I didn't put on queues or anything, which is not smart because you'll run out or the user gets bored waiting. But it's pretty easy to queue it up, and you could look at Llama for all that. So we're just going to run this guy. And another thing I like to do, actually I use Warp for this. So in Warp, I just go into the folder and I'll do a tail F, and I just keep an eye on that if I have to. But I think because this is so basic, it should be done. And it was only a few files, I forgot about that. And if we roll this, we have a bunch. Now we have 187 chunks, because remember they overlap. And we'll see later on they have a sort order. And that helps us to put them back together later on. As well as this takes forever to scroll, as well as a section number. And so they have a certain connection per file. That should cover us there. Now, one thing they don't have is a bigger document, and I really like that, where I have a model called document and it has chunks, because then each one of these files would have been a document, and then we could find its chunks. It's a little nicer, but I didn't want to complicate things. Alright, so at this point we now have our data in the system. We have it chunked. You'll see that the column it used was 1024 because that's the size of that particular model. So if we go back here, we're using Ollama, and it's a model. Oops, sorry. We're using this model here. And if you scroll up, you'll see that it's 1024. Alright, so now let's start chatting with the data. So this is there's a lot to think about here, but it's really easy overall. So first we have a question: what is a facade? And then we're going to take the question and embed it. So again, we're going to hand it over to a provider. Since embedding is done well by Ollama or OpenAI, we'll use Ollama. And we're going to give it that text to give us an embedding, which we saw a moment ago. So let's do that really quick, and then we'll walk through the process. Okay, so you'll see here that we have our question, we have the driver we're going to send it to, and I'm going to hard code Ollama here just so we don't do the config thing, just so we can see it. And now let's send it the question, and it's going to hit that route. Oops. It's going to hit that route and do its thing, and then return. That was pretty quick, actually. And remember, if you have an M1 Mac or M2, it could be a little slower. And it gives us a vector representation of that question. Crazy stuff, really. And now let's use that. So now that we have that embedding, we're going to use it to query the database. So now we say, okay, here's our query embedded question. We get it back and pass the embedding part of that. We know the size because we've done it before, and you don't have to hard code it. You saw in the code how we can just dynamically call it. And we're going to use the distance query with the cosine distance. So let's go look at that guy. And again, there's a test for it, so you can see it working. But let's just go look at let's look at the test. This is interesting. So we grab a bunch of test files, we make some chunks out of them, then we do our search, which is already vectorized, so we're not hitting anything for real, and then we pass it to the distance query and we get a result. Let's go look at that. So all it wants is the embedding size and the vector, and it says, okay, I'm going to query your database. I'm going to order in order by, because I want to use these later on. And actually, this is interesting. Maybe I shouldn't do this because I want the nearest neighbor to do some work. But when you look at the nearest neighbor class, there are some limitations to the results you get back. But here we have this one, and I'm using cosine, and I mentioned it in the article why. It seems to really be a good way to go with a RAG system. And then we get our results, and I just try to limit them, and I use the collect to try and help clean them up. But then the neat part is I then go grab the siblings. So I just go through the process of saying, okay, what are you, 0 or 1? And I see anything above or below you. There's a little bit of, I haven't checked this yet because when the original code had the whole document parent thing to help out. So, I haven't really, the test passed, but I haven't dug into the quality. So I would like to take this. If you look at the Laravel code, you'll see how we use a document, the parent, to help establish a grouping as well. Alright, so now when we take our embedding, we do the distance query, we're going to get some content, we're going to just clean up the content a little. This isn't always needed, but I did hit some gotchas in the past. And then we're going to implode that content. So let's just do that for a moment. Let's pound this out here. And let's just, I think I need a DD. I think this guy just shows it on the right. So you'll see it found some content about facades. It's more than just a keyword search, it's doing a vector search. And this data is slightly, in my opinion, verbose, like with all of this stuff here that doesn't really add value. So if I was to go at this again, I would probably break up this data differently, whether that means smaller chunks or that's what I would probably do in this case, just smaller chunks. You could strip out all the links or sections, but anyway, smaller chunks would be a good start. Okay, so we have our data from that search result. Now let's open this up a bit. Let's just look at the article so we don't lose track. And we see how to pass it, we see how to get the embed data, we see how we are doing the distance query. And we did look at this, nearest neighbor. And now let's do it for real and see what happens. So now we're giving, this is actually the key part. Now we're giving the context we just grabbed into a prompt. In this prompt, you could run inside of ChatGPT. Let me explain that. Let's do this. I have these little shortcuts called put and get fixtures. So we're going to say it's really a text file, prompt, false. So before I send this off to Olama or whatever, I'm using Claude because it's fast and I wanted to do something a little bit different here. Let's run this for a moment. And what we're going to see is this raw text. Oops, I don't want to go there. And my point is, this is the text. This is what it all comes down to, is a decent prompt with context, with user input, and with guidance in the role task format or whatever works. Now here's the thing. I could take this text and go to Claude and I can just paste it in there, and that's how you could just quickly iterate from prompt to prompt. Maybe change the roles, maybe change the format without having to hit your system over and over, and just quickly go forward. Now it's the same thing because we have limited the context, we've limited the scope, we've asked it to stick. I don't know if this guy lets me set temperature in here, but that's the one thing we're not doing in here, and that is actually a big deal. Let's see. Yeah, I don't see how to set temperature right here. So that's something to keep in mind, is that you want to be able to set the temperature to 0. And if we go to their playground, we'd actually be able to do that more easily. I don't know where their playground is. Basically, you could go there and force that particular setting. And the temperature 0 is key because it prevents it from drifting, or what people say is hallucinating. So when you look at the OpenAI client we have, when you do a completion with it, we set the temperature to 0. Right here we do not, and I think it's just missing that setting. It should have been added there as well. Alright, so we can see though that we have a prompt. We can just play around with another system, get good at the prompt itself. We have the context, which is really the important part. A RAG system gives you a place to store context, centralize it, update it automatically with scheduled inputs or sources like email. So it really separates everything else from just a regular chat GPT interface. But now let's do it all together. We're going to take that prompt and do a regular completion with Claude. So again, just normal stuff here. You're going to use the Claude driver, which is just a post request. So let's go look at completion. And it's just going to say, okay, give me that prompt. Let's grab the token in the model, and let's just do a get request. Let's get the client and do a request using the client. And then we'll get our results, and we'll just conform them back to this completion response. And that is it. When we do this, we're going to get content. Let's give it a go. Just like we saw in that chat window. Oops, sometimes I click in the wrong area. Let's do that again. You got to put your cursor down there, or I'm clicking the wrong thing. And there we go. We used, that's cool, we used Olama here to embed, and we used Claude down here to get the completion. And then it gives a decent answer based on the content it has. And it actually, I don't know if I'm setting the temperature in cloud to 0. Let's see if we can do that really quick. All right, let's set that right there. Their docs seem to say that works. And let's give it a run again. And that is actually really key. You just want to make sure to set temperature to 0. If you want to give it a little bit more creative room, just keep going up, I think by decimal points. Let's go look what we're waiting. Defaults to 1, range is 0, 0 to 1, 0. So yeah, so 0, 1, 0, 2. But you don't want to give it too much creativity. And then the results should be consistent, not consistent, should be in context with what you gave it. And it should not drift. And I mentioned that in my article, that it will show that it will not drift. Or we can keep it from drifting. Let me show you that really quick. If we go back to the article, we'll see that I show an example of where it actually says, hey, this isn't a ton of data. I can tell you what I can tell you. But then we even have other ones where it doesn't have anything about this. It just doesn't try to make it up. And that's really important here. A good RAG system with good prompts and good temperature setting will keep your system from drifting. But that's about it. Hopefully you see how easy this is to really get started. And with the HTTP library from Laravel, you can really hit any API you want and mock them and test them and so much. So you really can have a go at any of these APIs. All right, here's some other links to check out.